welcome to the History Center's 12th season of Roundtables. We're having a little technical difficulties, as you probably have gathered, but I hope you're all partaking of the coffee and tea in the back and the things to eat. I had to have a few thank yous I want to say. One was to the St. Anne's Church, Father Joseph, for the sharing of this continued sharing of the facilities here, and to MCAT for their continued filming of the programs of the roundtables. And they're going to be available on their website on demand, channel 189, in probably a few weeks, 2 or 3 weeks. And and they will also show the program on MCAT twice, so you can see it there if you know people who haven't seen it. Anyway, hopefully we'll get it going today. And our two technicians who keep the sound going, Joe Braun and Walter Peckham, and Friends of Two Rivers who support the History Center. And probably an important thing that I should tell you, that the bathrooms are over behind the behind the barriers over there. And I guess we'll just wait a few minutes more until...
I can start doing the short version of Lake Missoula.
Okay. All right. This is Jim Shelden, who recently retired as the geologist in the regional office of the Forest Service of Region 1. And he's also president of the Glacial Lake Missoula chapter of the Ice Age Flood Institute. Anyway, he can explain all that to you. And so let's welcome Jim Shelden.
Commercials. The story of Lake Missoula and the Great Ice Age floods has just recently been authorized by our terribly polarized Congress without no votes as the nation's first and only National Geologic Trail. The Ice Age Floods Institute.
Sir, I wear hearing aids, and I'll bet I'm not the only one. Please use the mic.
You bet. I got you. Yeah. Except I've lost one, so keep an eye out. Dang, okay. The Ice Age Floods Institute is a nonprofit that works with the Park Service to get this trail built and make it a reality. So that's what my group spends its time doing. If you've either seen in the newspaper or seen when you're out hiking, you come across a big boulder that says elevation 4250, the high water mark of Lake Missoula. That's some of the stuff that we spread around the valley. Now, our mission, as authorized by Congress, is to use the story of Lake Missoula floods for teaching science in the schools and for diversifying and strengthening the tourist economy of small rural places that don't have much to attract tourists but they do have some great Lake Missoula features around them. And so we are in the process of that. Probably our best success and best example of that is the Paradise School. The people in Paradise are trying to save their old school, make it a community center and a performance center for various things. And one way to keep a steadier flow of money coming in is to be a node on the Ice Age Floods Trail. Now they got a grant, and they built the most accurate model of northwestern Montana that's ever been built. Just going up to see that model will blow you away. It's very spectacular. So I would encourage you to make a little weekend trip out of that. And if you do, then you need to pick up a brochure at the Natural History Center. And this brochure is tied to the driving loop up in the area of Paradise. And you can download a little software onto your phone and download this map with the numbers on it. The numbers tie to descriptions of the things, and then you'll get the map on your phone with a little blue dot, and the little blue dot is you. And you can then use that to navigate with confidence to all of the noted Lake Missoula features in the area and get a readout of it and know you didn't miss a turn or worry about getting lost. So I would encourage you to all do that. So, do we have any Lake Missoula newbies? Really doesn't know the story. Okay, we'll start from scratch. This is a map of the Northwest. Missoula is here between these two patches of ice right here. The story begins over at Sandpoint. This is the Purcell Trench. The Purcell Trench gets its own offshoot of ice off the continental lobe. Now it's important you understand the difference between continental ice and mountain ice. Mountain ice, here in Montana, the Bitterroot Glacier National Park, you can go all over and see good examples of the mountain ice and see the bathtub ring, how high the ice got. And in general, in Montana, in the dry parts of Montana, the mountain ice was maybe 500 to 800 feet thick. In the wetter corner, the ice was generally about 1,000 feet thick, might go to 1,200 feet thick. The continental ice is about 2,000 feet thick and goes to about 5,000 feet thick, where it kind of piles up or gets trapped in a trench like the Purcell Trench. So, the Purcell Trench, right at Sandpoint, Green Monarch Mountain, sits at the end of the trench at 90 degrees. The ice comes down, hit Green Monarch Mountain, and we have us an ice dam. So, all the water that's to the west, or to the east of that ice dam, starts pooling into a big lake, Lake Missoula. Okay, Flathead Lake is about 300, and deepest spot's about 370. Okay, Lake Missoula was 2,000 feet deep. The average Great Lake is on the order of anywhere from a couple of 100 feet to 300 feet deep. So Lake Missoula is two Great Lakes stacked one on top of the other. It would be the equivalent of Erie and Huron, stacked one on top of the other. Now, most lakes sit down in a bowl. So if anything happens, you can't lose much water out of it. Maybe some water, but not very much. Now, Lake Missoula is a flooded river valley. So that whole 2,000 feet ahead is available to push on the dam and to take off and go somewhere if anything happens to the dam. So this would build up to around 4,000 feet of elevation, 2,000 feet in depth, and then something would happen to the dam. The dams would fail. All indications are the dam would fail very rapidly. Now there are, in the area of the dam, we used to argue all the time about how did the dam fail. And we've come to realize there's lots of ways for an ice dam to fail. And we're getting lots of new examples all the time as we watch Greenland melt. You've seen the pictures on TV, the giant lakes on top of the ice, and then they get a hole in the bottom and all go pouring out down through those things come roaring out the snout wherever the interface between ice and air is. Those things come roaring under the glacier and come blow out the snout. Okay, so and that erodes the snout very rapidly. So that's one way you can do it. The Galloping Glacier, where you periodically, about every 10 years, you see this crying story about the whales trapped behind the ice dam, and when the ice dam busts, it'll probably kill the whales and the dolphins and all this stuff. And then the ice dam busts, and we don't know what happens to the whales, but they're not bobbing around dead at the end. That glacier typically bursts. It overflows the top, and once you get flow over the top, then friction very rapidly cuts a Grand Canyon in the ice, and it drains very rapidly. Now, and that type of failure ties in with something else. This is the ice line for the whole ice age. As you can see, our ice dam is very close to as far down as the ice would have come anyway. It was just about at the stage where there was as much ice melting as there was coming down in the winter. And that tells you two things. You're near the terminus of where the ice would have been anyway, and your ice is warm. It gets warmed up every summer, and it's very near the melting point, so anything that gives it any extra heat, like the friction of water flowing over it, and then a lot of water flowing over it very rapidly, will give you enough heat to melt a huge amount of ice very rapidly, okay? But my favorite way is, you're familiar with landslides. If you cut the toe out of a steep slope, then you get these rotational things. The toe goes out and the flat top comes down somewhere. Okay, that's called rotational failure. Now, the cute thing is, in the normal situation, when you do that, a bunch of dirt piles up at the toe. The next slide starts, but gradually you pile up enough dirt at the end that it weighs more than any failure slab weighs, and so they can't push that toe out of the way, so the landslide stops. But in this situation, the toe is in 2,000 feet of water, and it's ice, so the toe keeps floating away. So once these things get started, they never stop. And that's how these ice dams were like 20 miles thick, 20 miles wide, up to 5,000 feet thick. If you are a skier, you can go to the top of Schweitzer and look up at the top of the hill. There's a little radio antenna up there. The ice was just about where that radio antenna is. And then you can look across the valley to Green Monarch Mountain, and it's the one mountain that sits right across the valley. And you can just mentally slope it with your eye from there down to the top of Green Monarch, and that's what our ice dam looked like. So it's at least 5 miles this way, 20 miles this way, 5,000 feet thick on this end, and about 3,000 feet thick on this end. So this is a huge mass of ice. But as long as you float the toe on this rotational failure method, they just keep going. So it gets started, and it just eats clear through to Farragut State Park, at which point you've turned the entire gigantic mass is busted up icebergs now, and it comes out the other end. It comes out the other end with 2,000 foot head on it. That's like 3 Lake Meads. Hoover Dam, 3 times as tall as Hoover Dam, 10 miles wide. So this is an enormous amount of water. This is equal to 10 times the flow of all the rivers in the world coming through Farragut State Park. There's no other flood, or there's no other type of flood like these big outburst floods anywhere on the planet. Okay, these are by a factor of 1,000,000 bigger than the next biggest flood you ever heard of. Okay, tremendously powerful. So it roars across Washington. All of this dark gray stuff are the flood channels that it cut across Washington. And it cut these channels anywhere from a couple hundred feet to 400 or 500 feet deeper, almost instantaneously. Ephrata and Soap Lake is the first plunge pool. There's a little cliff there, and the water came out of the canyon near Grand Coulee and came down next to the ice. This is Grand Coulee here, until it got to Ephrata and came over that waterfall, and that waterfall started eating backwards. And then halfway up Grand Coulee now, you'll see Dry Falls. Okay, that's how far Dry Falls went from Ephrata to its present location as a result of the floods. That's about 10 miles of 600-700 feet of hard black basalt. That's how fast this thing was eroding. Okay, and it's the same through all of the flood channels. Plus, as we described earlier, you have turned your entire ice dam into ice cubes. So it's trying to get down these channels, but it doesn't have enough water to really lube itself. So it's making temporary iceberg dams all along the way, and they're overflowing, flowing off across country, connecting in with other flood things. So there's a system of these interconnected channelways, and they're all black, and they call it, that's the channel scablands or the scablands of eastern Washington. It gets down to Walla Walla. At Walla Walla is Wallula Gap. It's a little narrow spot, 2 ridges, got a notch cut in them. Now, our choke up here in Montana is Eddy Narrows. Eddy Narrows determined how fast Montana could let water out. And with a 2,000-foot head, we're letting water out about 3 times faster than Wallula Gap can let it through on its end. So as soon as the water hits Wallula Gap, plus the icebergs tending to plug everything up, you get a temporary dam, either a hydraulic dam or a combined ice and hydraulic dam, and you start backing up this big lake, Lake Lewis, in the area of Tri-Cities. Okay, that gradually dribbles off and it hits the gorge. Now the gorge can't handle as much water as Eddy Narrows is letting out, so you have another temporary lake about where the first bridge across the gorge is, and it backs up a temporary lake in the Hermiston Pendleton country, and then it makes it out through the gorge, and the next narrow spot is below Portland. It backs up all the way into the Willamette Valley. All of the good agricultural soils in the Willamette Valley are mud from somewhere upstream. It dribbles off, finally makes it to Astoria, and now we're right at the height of the ice ages when this thing starts. Max ice, about 20,000 years ago is max ice. The first big flood was about 18,000 years ago. So we just reached max ice, and we have a climate change about like we have going on now. Right next to the ice, and say down to Missoula. From Missoula north, things were kind of Arctic-y, notably cooler. But we know by the time you get to Lost Trail Pass, there's a little pond down there that didn't get scraped out by the ice, so we have pollen and mud from the whole last half of the ice age down there. And 80 miles away from, now the ice is stalled out at Polson. The Polson moraine is as far south as glacial or continental ice made it. Okay, and Lake Missoula stood. The Polson Airport is almost identically the same elevation as Missoula and our airport. So the Lake Missoula stood 1,000 feet deep against the 2,000, 3,000 foot ice cliff there at the end of Flathead Lake for the big floods. Now we also know that the littler floods, now it's getting warmer and warmer, more and more ice is melting. All the ice is getting smaller and smaller until finally Lake Missoula can flood up through Flathead Lake and past it. But we don't know how far. Up in that end of the world, we've got lake beds and beaches galore, and we can't separate Lake Missoula beaches and phenomena from Big Flathead Lake phenomena. So we don't know how far into the Flathead Valley it got, but we know that the later Lake Missoulas did get up that far. Okay, so that is kind of the quick and bloody short story. I guess the other thing to just kind of reinforce is it's really hard to get your head around just how big this thing was. And the lake was capable. Now, Eddie Narrows was capable of letting water out of the lake fast enough that, barring ice jams, if it was just a straight flowing chute, we could have emptied Lake Missoula in 3 days. Now, due to temporary jams and blockages in hydraulic dams, I suspect we rarely managed to do it quite that fast. But Lake Missoula emptied very quickly, horrendously, with horrendous flow rates and horrendous erosion rates, and it pretty much activated all of that gray flood path all at once. And you need to drive through there to kind of get some other ways down in in spite of the name, Grand Coulee is truly a Grand Coulee, but it's not the biggest. The biggest is over here in Sprague-Steptoe country, the Washtenaw Coulee. And then the Washtenaw Coulee, the highway goes right down the middle of it. So you can take any crossroads, drive east or west until you find a cliff, a big cliff, about 300 to 600 feet tall. When you find that cliff, that's that edge of the coulee. Drive back to the main road, go the other way, and you drive 9 or 10 miles that way over the curve of the earth. You can't see the rest of the coulee from either side, and the flood's 600 feet deep. Okay, this is when your mind starts to rebel, but you get the idea. This thing is really, really large because there's 3 other giant coulees. This is Grand Coulee, and this is Crab Creek coming out of this dark area here. So there's 3 other giant sets of coulees flowing at the same. Plus, when this ice, the Okanagan lobe, is out, the Columbia Gorge is carrying. It's a major flood path, and it's carrying all the water it can, all at the same time. Okay, so with that, do we have any questions?
Where's the choke point in Montana?
Eddie Narrows. It's about, say 5 miles above Thompson Falls. Between Thompson Falls and Plains.
There's a mark right there.
There will be.
Good answer.
This fella.
Yeah, you mentioned the first flood 18,000 years ago. When was the most recent one?
That is harder to tell and date, but the ice was pretty well gone by 10,000.
Okay, so let me just interrupt a minute. Anna back in the back has a traveling mic, and this is being recorded so that others can see it too. So if you raise your hand, let Anna get to you before you ask your question, and then everybody can hear the question and everybody will know what the answer means. So thank you.
So certainly by 10,000, we don't have any more ice to make the damn thing. However, I would point out that if you pick up the mud flat there at the St. Regis Golf Course, you'll follow it up through Quartz Creek, up to Tarkio Flats, and it kind of peters out there. But that little mud flat, that's one of the last. All of that ground would have been slicked out to bedrock in a big flood. So that is some of the last little tiny floods, and it's still pretty flat. And there's a few places where the main creeks that carry water cut a ditch in it, but it's pretty undissected. There's not many. That's a billiard table flat mud surface. So that is one of the last Lake Missoulas that came very far into Montana. As they got smaller and smaller, of course, they stayed closer and closer to Sandpoint. But that little lake was pretty shallow. It was just a mud flat from Tarkio to St. Regis, so it wasn't very deep at all there. And that one, we do have some ages on, and it's in the 17,000 year range. So once the ice started melting big time and the big ice got blown apart a couple of times, the last Lake Missoulas, they tapered off relatively quick. The middle to last Lake Missoulas appear to be quite a bit smaller than the early ones. Now, here in our valley, the ridge that the airport sits on, and the little ridge that connects Council Hill to the airport, that's the bottom of Lake Missoula. So everything below that level is how much mud has been cleaned out of the valley since Lake Missoula quit running. And that's actually quite a bit of mud. So the Clark Fork hasn't been a clear, blue, beautiful, sparkling Montana stream up until fairly recently. It was carrying latte-colored mud as hard as it could do for a long, long time to dig that big hole. So we're still kind of in the mode of recovering and totally readjusting to Lake Missoula to this day. And that kind of segues into, are you ready for your talk, Lynn?
Yeah, I'll do it. 'Cause this...
Was the Palouse Country formed as a result of Lake Missoula?
Yes. Now, the question got asked not too long ago, 10, 15 years ago. The geometry didn't change through the three ice ages before Lake Missoula. Did Lake Missoula function in the earlier ice ages? So that kicked off everybody looking at all the well logs, all of the older than Lake Missoula deposits they could find, and it turns out the answer is yes. There were older Lake Missoulas, which kind of solves a problem because some of the biggest floods, the earliest floods, cut some Palouse soils. So you say, how did the Palouse form if the earliest Lake Missoula flood cut the dirt? Well, that dirt that got cut was from one of the earlier Lake Missoulas from the earlier ice ages. So as long as we've been having ice ages, we've been having ice dams and Lake Missoulas, and that big temporary lake around the Tri-Cities, Lake Lewis, that is a giant mud flat, and the wind blew at least as hard then as it does now, and it blew all of the fine part of the mud this way. Now, as the soils are sandiest near the Tri-Cities, and they get better and better topsoil as you come this way. And the Palouse proper is some of the better topsoil. So in the Palouse, you have anywhere from 50 to 200 feet of topsoil as an agricultural growing medium, making it one of the most fertile dryland areas in the entire world. Places that have good ground, they typically, even with irrigation, oftentimes have yields in the 60 to 70. Worldwide, if you can get 60 to 70 bushels, that's great wheat country. In the Palouse, they routinely have county averages of 110, 120, 130 bushels to the acre. Now that kind of feeds into the whole story. The Ukraine, the yellow loess, the soil is called loess, the yellow loess of China, all of those result from the mud flats from these big outburst floods. And it truly feeds the world. The world feeds itself off of the loess that blows off of these big outburst floods. So it turns out to really be an important thing. Now here in Montana, when I was going to school, most of you are familiar with our local quartzites and argillites called the belt rocks. And they're like a bunch of busted up cue balls. There's nothing there. There's no dirt in those things. And they kept trying to tell us that the fine brown forest soils that the trees grow on was an erosion product, that's what the belt rocks turn into. Just recently, it's occurred to somebody that the wind didn't quit at the border, and all in western Montana, all of our light brown gneiss forest soils, they're Palouse soils too. They blew over the hill. And so that's why it's very important to Montana also. We had you have the combination of the topsoil, and then you have periodic shots of fertilizer like Mount St. Helens from the Cascade volcanoes. And wherever you have that mix of Palouse soils with volcanic ash in it, that's a very rich soil. The redeposited version of that washed down out of the mountains and pooled up in the Missoula Valley, that's the Garden City soils that are wonderful to raise stuff on. I live up on the lake beds, and if you can get a carrot or a beet that doesn't grow above ground, you're lucky. But that redeposited Palouse soil, even over here in Missoula, that's where the good stuff grows. In the deltas out in the forest, that's where the big trees grow. It's still very important to us, okay?
I was just wondering if you could talk about Waterworks Hill, and is that design of Waterworks Hill anything to do with Lake Missoula?
Waterworks Hill, that's a talk in itself. The Clark Fork didn't always flow the direction it's flowing now, so you've got a change in direction in there. Waterworks Hill is actually a bedrock bench from a very early stage of the Clark Fork River that you can trace at least to 9 Mile, maybe farther. So it's basically not a Lake Missoula feature, but it's part of a really cool story all of its own.
Did the breaking of the dams and the letting loose of the floods have anything to do with the development of the Columbia Bar being so difficult to navigate into the Columbia River for the ocean-going pilots?
Not of the... Now, during the Ice Age, we had so much water tied up in ice cap. The sea levels were 300 to 500 feet lower than they are now. So in Lake Missoula time, the mouth and the bar were 18 miles far out in the middle of the ocean. On this other map around the corner here, that has the Ice Age coastline on it. And that'll show that. But the modern bar it's a modern, after Lake Missoula cleaned out the old bar, slick as a whistle. Now the recovery from Lake Missoula made a whole lot of mud flat and destroyed the vegetation over a huge area. All of that stuff immediately had because there's nothing growing on it, it had a huge erosion rate. And that big slug of erosion to try to clean out the Lake Missoula deposits along the floodway, that's what built the new bar. Okay? Okay, got the yellow shirt.
Everybody in this room has friends and relatives that come into Missoula, and they look up at Mount Jumbo or Mount Sentinel and they ask a question, and then everybody in this room will say those were created by Glacial Lake Missoula. But then those friends and relatives want to know more. And in my case, I say there's 30 or 33 of those old beach lines. Then they say, what does that mean? I said, well, those must have been formed by 33 different fillings and empties. Empties?
Emptying, yes.
And but I can't really say what the chronology is from the lowest beach to the uppermost beach. Because I can't imagine that every refill was slightly lower, slightly lower, slightly lower for 33 times.
Okay, now there's a general, the early Lake Missoulas were the biggest, so the tallest are definitely the earliest. But as you come down the hill now, and I base this on looking at steep-sided, artificially dammed reservoirs are the best model for Lake Missoula. And like Dworshak, every time you have a big, blasty, windy day, that's just loose sand and slope wash on the hills there. Okay, every time you generate big waves, you can generate a beach in a day. As soon as the wind quits blowing and the rain quits falling, you go out there and there's a beach at whatever level the lake was at that day. Now has a beach there. So in the tall beaches are the oldest. The bottom beaches are probably the youngest. Now there's something happens if you notice the little gulches coming down off the hill. They start out and they get bigger and bigger and bigger and more powerful. Then about halfway down the hill, they get skinny and less and less powerful to the bottom. I think and that's really hard to do hydrologically, is to gain power in a gully and then lose power that fast. So I think what you're seeing there is the lake spent a lot of time kind of in the middle, and those gullies lose power when the gullies went into the water in the lake. And the fact that they lose power in that same kind of general interval kind of tells you that most Lake Missoula spent a fair amount of time in that area. Okay? But other than that, I think they're one lake, depending on how the storms hit, could have made 10 beaches, and maybe a lot of lakes, the beaches got overwritten by bigger storm events later on, and so there's really no beaches for that lake at all. So I think it's really hard to say much other than the tall beaches are old, the short beaches are young, and all the beaches in between just tell you there was a big storm that day.
But when we see those famous pictures of the white lines, the white line is accentuated by the white snow.
Yes.
Very accentuated. They seem almost equidistant and equal length. And when as a botanist, I go up on there, Mount Sentinel above the campus, and that's where Festuca scabrella, the rough fescue, is dominated because it's wetter. And then between the beach lines, you have the other Idaho fescue. So if you really want to find out as a geologist what really went on, you have to almost be a botanist also.
Yes, and that is true for many things in Lake Missoula now. There's the beaches right close to where the beach line shows. In that interval, they transmit water horizontally much better than they do in the middle. And I suspect that's what your grass is telling you.
Dry, wet, dry, wet.
Yes. And that has to do with where the beaches actually show are the sandiest with the most fines, and they dry out fastest. But in the snow melt, they also get saturated and they transmit water sideways to the Hellgate Cut or to something else on the side, one of those little gullies, and that's where the water or the moisture gets into the little gullies in the springtime now. So there's the other thing is if you just look at the mountains, basically the trees, particularly on the south and the southwest slopes, come down to the top of Lake Missoula. Below Lake Missoula levels, where you have the finer grained soils, the trees can never conquer the grass. And between fire regime and the grass being more competitive in fine grained soils, that pretty well determines where your trees are and aren't. And it tells you that those grasslands will stay grasslands forevermore. So all around Lake Missoula, there are little. You have to be a bug guy. It even seems to influence the insects. You have to be a bug guy, a botanist, to pick up on all of these little things that Lake Missoula influences. But it's a lot.
Well, we can tell all our friends and relatives the right answer now.
Yes.
So is there an approximation of the number of Lake Missoulas there actually were, or can anybody approximate that number?
Okay. 15 years ago, we'd counted everything that we didn't think was doubled, including Burlingame Canyon and Yakima. And the number was either 122 or 128, but over 100. Now, Dave Alt, his first try out at 9 Mile, he come up with 44. Okay, you like 93 based, or 33 based on the beach lines, and that's about right. So we have all kinds of estimates. Now, the one thing that really queers the estimates farther down the valley, the farther down the valley you go, the bigger the number is. And we've just started, the Yakima Valley is case in point. Floodwater and mud could go in it, but it couldn't go out. And the Yakima River was never big enough to even come close to excavating all that mud between events. So it has a long record of in events that haven't been destroyed by the river. However, we just become aware that some of those we used to count as Lake Missoula floods probably are not. At the same time Lake Missoula was, now remember, we're melting 100,000, 200,000 years worth of ice in 1,000 years. So the water's just pouring out of here. We're really melting, so we have a lot of water to power a lot of things. Okay, one problem that's always sort of bothered the floodies is the farthest west Coulee, Moses Coulee. Moses Coulee seems to have a different character than all of the other coulees, and it seems to be maybe a little older, a little gentler. But when you walk out the top of Moses Coulee, you're out in this guy's wheat field, and you're on top of the mountain. You're looking down at Grand Coulee. Grand Coulee is a couple of 100 feet below you. Grand Coulee would be running. All of these other great coulees would be running before you can activate Moses Coulee. But Moses Coulee is every bit as big as Grand Coulee, and there's nothing to hold water but sky. Okay? So you've seen these pictures in the news here lately of these giant lakes developing on top of the ice cap as the ice melts. And in Greenland, they find a hole in the ice, and disappear down there, and they come shooting out in the ocean someplace. Out on the main ice cap, they just flow through into the ocean through a crack and whatnot. But I think the only place for the water to make Moses Coulee could possibly have come from is someplace up there, which means it's on top of the ice. So I think we had evidence for big floods coming off of the ice. Then the Omak Valley, just like Lake Missoula, has defined a suite of landforms. That when you find these landforms, giant ripple marks, giant bars, streamlined islands, you know there's been an outburst flood. You may not know, you have to do some hunting for where the dam was and figure out the story, but when you see this, you know there's been an outburst flood. There's a similar suite of landforms that define a flood that is trapped between the bottom of the ice and bedrock. And those landforms are called Rogan terrains. And the Omak Valley has Rogan terrain. There may even be some Rogan terrain up around Eureka to the north of us, which is really a head scratcher. But where there are signs, and the Canadians are very big on this. Matter of fact, they identified Rogan terrain and caught on to this idea before any of the rest of us, is that on those places where those giant lakes drain down through a glacier and come shooting out the bottom, floods are as big, or they're on the order of magnitude of Lake Missoula, but they're totally encased in ice till they blow out the other end. Okay, so with those little bits of added information and the evidence that we had those kind of floods coming off of our ice cap too, we can't say that all of the bud bands in Yakima are Lake Missoula. They could have been some of these other phenomena.
Bring you guys up to date a little. We need an HDMI cable to connect my laptop to the projector. So that's a fellow that was helping me here has run home to get it, and he lives by the university, so he figured a half an hour from the time he went to get it and come back. So I thought, Jim will talk, I'll talk. Maybe if we're still killing time, he could have a cookie, and then we could start the movie. We have a movie, and I have a PowerPoint. I'm going to tell you everything that's in the PowerPoint. We'll just pretend we're on a bus trip, and I'll describe things. That's okay. How's that sound? Does that sound all right?
If some of you people want to see a visible evidence of where Lake Missoula is, you go down past Dixon, where they used to have the town of Perma, and you can pull over there and you can look up. In between it, you will see up high a flat fill. And if you go to Paradise, you will see that up there too, and all down through Thompson Falls. But if you go up Beaver Creek, which is between Thompson Falls and Trout Creek, they used to have a little hill that you went over that they are using for gravel pit. And if you go up where you want to go to Cherry Creek and Prospect Creek, or take the Thompson Falls Pass into Idaho, you go over a hill, and these hills are just kind of like where the river kind of flows sediment along the edge, and that's part of Lake Missoula. But the biggest evidence is looking, Thompson Falls, Paradise, and Perma up on the top of the ridge, and you can see where it's been filled.
Those are eddy deposits.
Yeah.
The water was flooding down. We're going to talk about two different things. We have a huge lake, Glacial Lake Missoula, right here, and then we've got the floods, the flood features that resulted from the release of the ice dam that I believe I was not listening real good while Jim was talking, so some of this is a repeat, I'm sorry, but there was an ice dam right here near Sandpoint, and it backed up all the water to Drummond, going east to up the Ovando Canyon, going northeast, all the way to Sula, to the south in the Bitterroot, and all the Flathead Lake area. And did Jim get into the party controversy at all? No. Okay. Then, as this woman was describing, we start getting into some flood features in western Montana. And one of the main ones were these giant ripple marks. Did Jim talk about that? Okay, they're near Hot Springs, Montana, Camas Prairie. And we had a geologist, his name was J.T. Pardee, who in 1909 wrote a paper on the valleys around in the Bitterroot Valley mostly, and he noticed some lake lines up 3 Mile that were puzzling to him. And then as he looked around Missoula, he saw all these lake lines. We'll call them Strand Lines. They, as noted, they aren't truly beaches. If you've ever been at a storm on Flathead Lake and watched those waves as they hit the shore, you start to understand how those ridges formed along. And they did indeed form terraces, and it is indeed defined by the vegetation. Yes, water likes to collect in the flat areas. That's why we terraced all through the Bitterroot Valley at one point, so we could get trees on those terraces. And that's another story. Anyway, what I want to talk to you about, because Jim gave you the overview, is your neighborhood. I want to talk about East Missoula and Bonner and going east. We had a field trip last summer and looked at some sites that we hadn't given too much thought to before, never even thought of having a field trip, so we learned a lot. But one thing I want to point out, they're pretty subtle. It was pretty, we just don't have the lake deposits, the features that we have in the other canyons. Elevation was only 338 feet, whereas here in Missoula it was 1,000 feet deep. So that's quite a difference in elevation of the lake and what it can do. Well, we started, and I guess that's all I need that for. Claudine, you can rest your arm. We started at Brickyard Hill and discovered it's all glacial lake sediments. The whole hill, Brickyard Hill, is lake sediments. And not only that, it was conducive to brick making. It's called why it's got its name. And we started talking to some people, and Bert Summers, he lives off of Summers Lane. It was named for him. It goes right out of East Missoula, Summers Lane. You can look for it. He lives at the end of the road, and he worked at that brickyard that was on Brickyard Hill. In fact, there were 26 brickyards in Missoula. It's probably why Missoula became Missoula, because the railroad needed those bricks to make stations with, and they were much more likely to put a railroad where they had that material. And I thought, well, why didn't they use timber? Well, the saws. In the turn of the century, they just didn't have the good saws to make things out of timber, and it was easier to make it out of bricks. Well, I know nothing about brick making, but I'm learning as we go. But I thought it was pretty interesting. And there's one by Grass Valley, by the airport. I'm kind of hoping to gain information from all of you and where these clay deposits were that they were making bricks with. Another feature around East Missoula are these big rocks. Now, if you'll drive through people's yards, everybody's got a big rock. A big, really big rock. And then if you go to the golf course, Canyon Creek, they have moved these rocks. Many times they have been moved, but they haven't moved far. No one wants to move them. There was a big deposit of, we call them erratics, because they were carried by ice. And what happened when the ice dam broke and the water came flooding west, we think there might have also been a release of water from the Blackfoot. We're not sure, but it carried all these huge rocks and dumped them because there was a big eddy against the backside of Mount Jumbo. And that slowed the water enough, this eddy that hit the backside of Jumbo, that it dropped those rocks. So, I don't know, that's a pretty neat feature to think of. And then also go to the new Milltown Dam, the new park down there, and you're going to see rocks laying around there too. Now, there's been a lot of construction. I'm not saying they haven't been moved, but I don't think all of them have been moved. Yeah, just head toward Deer Creek. Yeah,
You know where the shooting range
up at
is?
200.
It's just up a couple blocks up the hill.
And I think too, if you go to the overlook, the Deer Creek overlook, you're gonna see some of this too. Yeah. So so that proliferation of rocks is pretty neat. You also see some by the Deer Creek Bridge. Get out there and walk around, and you'll see some of those. Okay, another feature by the bridge is the railroad cut that goes through the target range there. Now there's big signs. You're not supposed to go there. Mindy and I did when we were getting for our field trip. Once you know it, the train has to come. I mean, it just never fails. So we wound up jumping behind bushes, and I thought, I'm 68 years old. What am I doing jumping behind bushes to take, but there I was. And the railroad cut's quite impressive. It's very tall. I have all this on a PowerPoint if we get a chance, and I'll show you that. But that's another deposit of Glacial Lake Missoula silts and clays, is that railroad cut. It's pretty impressive. They're a little skimpier to find now as we're heading east on I-90. Get past Bearmouth, and it's Mulkey Gulch and Garden Gulch, and we accessed it through the frontage road. Now you can also see this on the interstate, but there's no place to stop. So we were able to get the landowner's position in our field trip, and we went down and looked at these sediments. There's been a great paper written by Larry Smith of Montana Tech, and he dated those sediments 20,000 years ago. So that's pretty old. That's the oldest that the lake was. So that's pretty neat. We know there's sediments. They're buff colored. They're made of rock flour, essentially. I've noticed as you get around Flathead Lake, the rock flour deposits are much lighter colored. These are characteristically buff. And you will see these buff layers of sediment. Once you look at one, you're not gonna mistake it for others, especially as you go toward Evero Hill, and through there you'll see a bunch, and the airport's loaded with them. One of the brick spots was at Grass Valley. Is Dusty Dayshaw here? Anyway, his land, I guess. I got to get there and take a picture of that. Finally, the lake level stopped at Gold Creek, and our chapter has been trying to put another sign or marker at Gold Creek to indicate this is the farthest east that Glacial Lake Missoula went. So we have 4 large markers. We've got 2 on Jumbo and 2 on Sentinel, all at 4,200 feet. Believe me, they were not easy to get up there. Just ask my husband, And we have one at Lake Como, too, in the Bitterroot. Yeah. Elevation. I mean, any body of water, even if it's always going to seek the same elevation. So 4,200, 4,250 was picked as the highest level because that's where all these stray rocks were found. That's the highest that they got. The highest, J.T. Pardee was the one that defined that, and it still holds true to this day. So I'm going to read you a poem by Pardee, because that's how I was going to end this. Or do I have it? No, I don't have it. If it comes up, I will, or I can get it up on the laptop. Yeah.
There's also pretty good evidence of that level, Glacier Lake Missoula, around Maxville, where all those rocks are on out in the field.
That's a little different.
Of the glacier receded and melted.
There was a big blowout.
Yes, and that same level is down by Hamilton. 3 different areas. There's whole acreages of those rocks.
Some of them are Lake Missoula. Some, there were all kinds of alpine glaciers up and down the Bitterroot. I'm sure they show in that one picture there. But so don't get confused with erratics that have come from the alpine glaciers and ones from Glacial Lake Missoula. It's always a puzzle that we're dealing with. Where did this come from?
It's a quick one.
Sure.
We
use the microphone.
We live in the mountains of, we're seismically active, keeps our mountains steep. Every big rock, every big blowout is not Lake Missoula. Maxville is a blowout on Boulder Creek. It's kind of like a miniature Lake Missoula, but it's not Lake Missoula. All those boulders are sitting on top of the Lake Missoula sediments in the area. In the Bitterroot, we had an avalanche into a lake, blew out the whole lake at once, scattered this big trail of boulders down across the valley. A lot of people think that's Lake Missoula, not Lake Missoula. So there's every big gravel pile or every big rock is not Lake Missoula. Alberton, the city of Alberton, got that huge pile of boulders on the west end. I would say 90% of people think those are Lake Missoula boulders. That's a thrust fault story, whole different deal. Not a thing to do with Lake Missoula. So you do have to kind of follow the evidence and follow the trail to make sure a lot of this stuff that we think is Lake Missoula actually is. Like I say, we got lots of other things. We're very geologically active, and lots of other things made big rocks and big piles of stuff.
I had a thought. I'm the council chairman here, Bonner Milltown Council Chairman, and during our council meeting Monday night, I simply asked everybody that thought they would come in here if they had been to the bison range. And there's a feature of the bison range that has impressed me a whole lot more than bison and the other animals that are there, which are impressive in their own. And that is at the top of the final hill on the trail as you're going out of, starting your way out of the bison range, there is a sign that says the top of Glacial Lake Missoula. Now, it's difficult to get an image from the maps and whatnot and say, okay, it's 2 Great Lakes stacked on top of each other. But if you're at the edge of this hill and you look out, and as far as you can see for 1,000, 1,500 feet below you, that's just part of Glacial Lake Missoula. So if you really want to get a visual image of what was maybe a third or less of not even that much, a small part of Glacial Lake Missoula, go to the Bison Range and look for that sign.
Oh, I agree. And if you look, take the road over Markle Pass, heading for Perma, take that, I think it's Highway 38, cut across road there, and there's another sign that describes the ripple marks, the giant ripple marks that are there. And it's well worth a stop and looking at. Also on the Bison Range, the corrals. If you ever go around to the corrals, the lake lines just jump out at you. There's no problem. And there's great erratics. No doubt about it, erratics. They have not been moved. They're huge. They're really neat. So yeah, look at those features as your, yeah. Yes, sir.
Who have our speakers been?
Oh. My name is Lynne Dickman, and I'm a retired geologist from the Forest Service. Got my bachelor's and master's out at the U, and I've worked on, worked in engineering for the Forest Service for about 6 years in the materials lab, and then got on as a geologist on the Bitterroot for 15 years, commuted from Missoula to Hamilton and Stevensville, and I was also zoned to the Panhandle. So I've gotten to know this area.
Thank you.
Sure, and Jim, tell them who you are. Come here.
My name is Jim Shelden. I am a retired Forest Service geologist too. I went to school at the University of Idaho. My father, however, was a map maker. And all the time growing, our routine was we'd map up north till we got snowed out, and then we'd go down and map around Southwest Desert and Arizona. And at the time, the nuclear facilities and the area for big copper exploration, he worked for the government, were the national priorities. So I grew up out in the Scablands because he was surveying Hanford and the reclamation project, which I got to throw in just another little quick one. Grand Coulee Dam sits where the old ice dam coming out of the Omak Trench sat, and the dam, present-day dam, sits there for a reason. The water would back up behind the ice dam there and overflow into Grand Coulee and follow the other flood tracks. So when they decided they wanted to irrigate that part of the world, the distributary canals were already dug. So that's why Grand Coulee sits where it sits. But anyway, I retired here in Missoula from the Forest Service, and it's my story. I've spent most of my time ore deposits, mining law, sand and gravel, building stone. So that's kind of what I worked on.
When I was a much younger undergraduate, I was fortunate enough to take a course from Dave Alt. It was the first I'd heard about Glacial Lake Missoula as a non-geology person. And it occurred to me that a lot of the archaeological evidence we have about human presence in this part of the world overlaps to some degree the Glacial Lake Missoula story. And I had to ask him, I said, do you think that some human somewhere was sitting up on the ridge when one of these ice things broke, and how thrilling that would be? And he looked at me and he says, well, I'd hate to think they missed it. I wonder if we have any new evidence about human presence in these glacial lake floods.
Well, if you've been following the news, we've got some really new discoveries, some of it based on DNA, some of it based on new thinking, and some of it based on new physical sites. But it's apparent now that there were people here at least 14,000, almost certainly 16,000 years ago. So they definitely overlap to that extent, and actually probably fairly well peopled by 16,000. Now the latest and greatest, there's always been this theory that they came down the coast, and when they got to the Columbia, they would have followed the easy walking and the easy eating, and followed the drainage network, particularly the salmon-carrying drainage network, inland, and staying to the places with the warmest winters, the easiest living. And for us, that's the Salmon River, Snake River Canyon. And indeed, they have just recently redated some sites in some lava tubes between Riggins and Cottonwood, Idaho. And they may very well be the very earliest on the continent. They're back in that 16, maybe pushing 18,000 year range. So that gets you well into the area where you started at, maybe you had Indians working their way in from the coast, but if you were on the coast or anywhere near the Columbia River drainage, you would have noticed these babies go by. And now they're in, they have the winter stories out at Lowell, Travelers Rest, and I've made it a point to attend those and talk to the speakers after the event. Do you guys have any knowledge or whatnot of anything that might be Lake Missoula and the Lemhi Shoshone? They say they're missing a clan, and it's the clan that lived north of the Bannock, up by the Big Lake. And when the Big Lake went to the ocean, they followed it. to see what the deal was, and decided the lobster and salmon life was a pretty good deal. And they haven't heard from those guys in a long time. When we made that map there, we sent it out to all the tribes to get their take on it, or just, are we offending you or offending your oral culture in any way? The Indians around Pendleton, the Indians around Pendleton sent us a nice letter back and says, your map matches our, we're not going to tell you what it is, but your map, we'd like some more because it matches our oral history perfectly. And their oral, all they would tell us is our oral history is based upon periodically the world just goes to hell, everybody dies. And if you notice this happening, you report to the sacred places. And if you report to the sacred places, you see who else shows up, and then you go out and repopulate the world. And all of our sacred places are above the flood. So there is some, I guess, some claim a some tribes claim a connection.
Looks like we can at least get the movie going. Do you want to get a cookie while I...
Imagine sitting on the shore of a massive lake covering the Missoula Valley and stretching 3,000 square miles in every direction. The water, enough to fill 2 Great Lakes, floods all but the tops of the tallest mountains in the western part of what is now Montana. Imagine a dam 7 statues of Liberty tall, made of crystalline blue ice. The dam fails, and the lake is gone in just a matter of days. This is the story of Glacial Lake Missoula and the catastrophic events shaping our landscape thousands of years ago. The echoes of those events can be heard today in the stories the rocks in the river tell those who are curious and who listen closely. This scene 18,000 years ago began when Glacial Lake Missoula was formed by a lobe of the Cordilleran ice sheet, 2,000 feet high and 30 miles long. The glacier, located at the Purcell Trench, a large valley at Sandpoint, Idaho, blocked the path of the Clark Fork River. As the water rose to the depth of 2,000 feet behind the giant dam, the lake embraced the flooded mountains with fjord-like arms. Those arms included the Bitterroot Valley to the south, the Flathead Valley to the north, and an eastern arm as far as Deer Lodge. The massive ice structure strained under the pressure of the backed-up water for a long time. The lake bed, composed of gravel and sediment compressed under pressure. Quiet waters lapped on the beaches of the extensive and intricate coastline, and mountaintops peaked above the water's surface.
When we walk around Montana and we see the rocks around us, a geologist's job is to be very observant and pay attention to those rocks and learn to tell the story of the history of the landscape. And the history of Lake Missoula is a great example, piecing together these different pieces of evidence, these different rocks and landscape forms that individually didn't make a lot of sense until we put them all together, and then we learned this really amazing story.
The ice fields built slowly over the course of 200,000 years. The Purcell lobe formed the dam, backing up the river's water behind it. As the climate warmed toward the end of the Ice Age, the ice began to melt. What had taken 200,000 years to build took a mere 2,000 years to vanish. The rising water and melting ice reached a critical breaking point. Dripping, slippery ice chunks released their hold from the massive glacier where the dam met the mountain. Calved icebergs floated on the lake. The front of the gigantic ice chunks bobbed in the water, pushed by howling winds and waves. The calving action triggered extensive sloughing, known as rotational failure, which chewed into the spine of the ice dam. This action was so powerful that the enormous dam broke, releasing a torrent of water. Glacial Lake Missoula was gone.
So there's no question, using this rotational mechanism, that we could have started on the Montana side and eaten clear through the core of the dam and gone out the Idaho side. Once you get started downhill on the Idaho side, the dam it's gone, because now you're working downhill on ever thinner, weaker ice.
The calving of other glacial lobes in the lake launched thousands of icebergs in a navy that sailed the rushing river and piled up in narrow canyons. The grinding ice left echoes on the landscape at Rainbow Lake, Eddy Narrows, and other locations along the river's course. The rushing water tore through northern Idaho, eastern Washington, the Columbia River Gorge, Oregon's Willamette Valley, and finally released its fury into the Pacific Ocean at Astoria. Imagine this cataclysmic event draining the entire ancient lake in not years, not months, but only a few days. Torrents of water destroying everything in its path. The sound must have been deafening. At once, the waters receded and the dripping canyons were silent. Total devastation. Scoured land, cleaned of all organic matter, scarred with ripples frozen in time and drainages instantaneously reshaped. Amazingly, this ice dam break happened not just one isolated time, but at least 2 and maybe as many as 100 times. The Purcell Trench refilling with ice, backing up the river, and then draining as if a giant had pulled a stopper out of a bathtub. The impact of the discovery of Glacial Lake Missoula's repeated and rapid flooding has changed the way scientists like J. Harlan Bretz, up to current researchers today, view epic events around the world. These monumental events happened so long ago. How can we know about these huge floods? Even though Glacial Lake Missoula is gone, there are clues that the curious geological detectives have followed in the last 100 years to piece together the puzzle of this ancient lake bed and the events shaping our landscape.
Follow the clues yourself and find more evidence of this amazing phenomenon in your own backyard. As you explore, post your photos on Instagram with hashtag Montana Natural History Center. Let's get started.
Traveling the back roads west of Missoula, you encounter a spectacular landscape with dramatic mountain views framing open plains along Highway 200 from Dixon to Heron. The sight of undulating 30-foot giant ripples frozen in time at Camas Prairie Basin is eerie and striking. How did they form, and what story do they tell about the massive outburst floods of Glacial Lake Missoula? The Camas Prairie ripples were a key piece of evidence advancing the theory of the rapid draining of the ancient lake.
Ripples are a great thing and a great visual to think about. So we've all been down to the river or down to the beach and seen ripples forming by the water. And usually the ripples we see forming on the beach, they're in shallow water, and these ripples are about an inch from one crest to the next. I've actually got some ripples here recorded in a rock, and you can see the difference from one crest to the next is about an inch. And this is a very natural process. It's due to the transport of sediment by the water moving over it. One of the real keys to breaking open the Lake Missoula story was when we realized that there were some ripples up in Camas Prairie just north of Missoula. But these were ripples where the distance between one crest to the next is now about 100 meters or about a football field. And the height difference is about 3 meters or about 10 feet. And we realized that these were ripples. They had to have been formed by water, but the scale of that water movement was nothing like what we are used to seeing. It must have been a huge flood, moving massive amounts of water and making ripples at a scale 100 times larger than we're used to seeing. The best place, honestly, to see the ripples is on Google Earth and to fly over Camas Prairie. They're just going to pop you're going to see them. They're going to look just like ripples you've seen anywhere else until you realize that it's a valley that you're looking at and not a small pond. You can drive there thinking this is the place that broke the Lake Missoula story open.
Head out to Camas Prairie to investigate the giant ripples that can be seen from space. Strain to hear the roar of the violent, ancient waters heaving gravel into undulating waves on the lake bottom. The ripples are now covered by quiet grasslands and vivid blue camas flowers in ancient still life.
Snap a photo and post it on the Montana Natural History Center website. #GLM Giant Ripples.
Patterns of light and dark of horizontally layered soil decorate sections of I-90 west of Missoula at 9 Mile. This geological artwork describes the rhythm of the ancient lake bed, the comings and goings that compressed the dark mud and light-colored silt into the lines and pages of the Glacial Lake story. Have the Rhythmites revealed the entire story? The answer is still being debated.
A rhythmite really means a sequence in the rocks that repeats itself over and over again. So what happens is in a rhythmite is we have a period of time where the water's going very fast and it carries big material or bigger material. And then we have a period where the water slows down and it drops smaller and smaller material. And in a rhythmite, this pattern repeats itself over and over again. It's rhythmic, so that's where the name rhythmite comes from. So Lake Missoula had several different rhythmites. The first one that we see in Missoula and the surrounding areas are the varves. And these are very common in glacial lakes. So in the summer, when the glaciers are actively melting, you have meltwater. It's carrying a bunch of rocks that are ground up by the glaciers into rock flour. And that rock flour is flowing out into the lake and it's getting deposited on the bottom of the lake. And it makes this big, thick, white deposit, the rock flour. And then the winter comes, it locks up the ice, the supply of the rock flour is cut off, and over the winter we deposit much less material. It makes a dark band, and then the next summer the process repeats itself. Those rhythmites are how we're trying to back out just how many times the lake actually filled and flooded. When we first put out the story of Lake Missoula, we thought it was one time. Then J. Harlan Bretz wrote a paper not too much longer where he said it filled and drained 3 or 4 times. When I was going to undergraduate school, we thought it filled and drained about 20 times. The current thought is that it could be anywhere between 20 and 100 times. As time goes on, we find evidence of more and more floods. I think the most important thing about a rhythmite is that it is recording individual events. It can be thought of much like a tree ring. It records an event that is repeatable, whether that's seasonal changes in a lake or repeated flooding and draining of the lake. As I learned more and more, I learned to understand that there were all kinds of rhythmites in nature recording these episodic flooding and receding type sequences. So I learned to interpret these repeatable sequences, think about history, think about how long earth processes go on. It really just brings out how much history a rock can contain.
Post your thoughts and photos on Instagram with #Montana Natural History Center.
Between Missoula and Sandpoint, the Clark Fork River squeezes through the rugged vertical walled canyons. Anywhere canyon walls close in, the rushing river increased speed. Imagine the canyon narrows or gorges as a giant hose nozzle formed by cliffs, spewing 500 cubic miles of water, 60 times the flow of the Amazon River, along with rocks, debris, and silt through the gap. The sheer force of the flood scoured the vertical rock faces, leaving grooves in the bedrock 340 to 400 feet above the river. The sheer power of the event at Eddy Narrows, for example, is mind-boggling. Boulders shot through the gorge without bouncing off the river bottom at the top of the cliff face, just like cannonballs from a cannon. What must it have been like? The evidence left behind helps describe it.
Eddy Narrows is where all 5 arms of Lake Missoula finally came together, and all the water had to flow through this point. This makes it the best place to measure the flow rate and the speed of the water. At the flow rate of Eddy Narrows, the lake could empty in about a little over 2 days, and it determined the character of much of the rest of the flood, how big the other temporary lakes were. So it is really an important item to be aware of in the flood.
Narrows are basically anywhere where you have a stream channel, and that channel gets forced into a smaller area. And a great analog to this is we've all taken a garden hose, and when you don't have your thumb over it, the water's pouring out really slowly. And then when we put our thumb over the garden hose, that water sprays out very fast. That's because you're forcing the same amount of water through a much smaller area. And so a narrows is exactly that in a stream channel. We've taken a large amount of water and we've forced it into a small area, and it becomes a bit like a jet nozzle. And that water's forced to move very, very fast in order to move the same amount of water through this small constriction. And so when we have narrows, that's where the whitewater is. When we talk about narrows of Glacial Lake Missoula, then we're talking about narrows at a whole nother scale. When the lake flooded, the river was about 2 kilometers wide, or 2,000 meters wide. That's a little over a mile wide. So you've got to really just expand everything you know and think that you've observed in a river at 100 meters, you got to multiply it by about 100. So it gets about 100 times wider and about 100 times deeper. But we're still in a narrows, so we're going to have rapids, we're going to have waves, we're going to get a lot of the same things we see in rivers today, but they're just much, much bigger. Almost all the roads in western Montana follow the river course and would have followed a natural drainage pattern of Glacial Lake Missoula. Anywhere where you see the sides or the mountains close in on the freeway, that would have been a narrows anywhere around Missoula. Right now, you enter Alberton Gorge, which is a modern day narrows. Alberton Gorge, the walls of the river close in, and where that happens, we increase the speed and depth of the river, and we get these big rapids. And that's where people go to play in the river and get in whitewater today.
Curiosity and imagination help drive the scientists to interpret the ancient events and understand the present-day world a little better. If you're curious, explore Eddy Narrows or the Alberton Gorge to see firsthand the power of the Ice Age flood. Take a selfie and post it on Instagram with hashtag Montana Natural History Center.
You may have noticed lonely boulders littering fields, housing developments, and even the University of Montana campus. These alien objects, some as big as a car, don't match their surroundings. Orphaned rocks called erratics tumbled in the torrent of floodwaters or carried on ice rafts caused by the release of the ice dam have been adopted by geologists as clues to ancient cataclysmic events.
An erratic is a piece of rock that does not belong where you find it. Anytime you see a large erratic or a large rock that is just sitting out in the middle of the valley on the lake sediments, that's almost certainly an erratic. Usually they are transported by ice or on ice being pushed by the glaciers. Most of our erratics are of another kind, and those are the kind that are on icebergs or in icebergs. And the iceberg calves into the lake and drifts around until the iceberg either melts in the lake water itself, in which it's not only an erratic, but it's also an erratic dropstone. Or we burst the dam, all the water drains out, and we leave the iceberg stranded and it melts in the sun. That's the most common kind of large erratic that we have. Right at the corrals at the Buffalo Range, there is a house-size erratic framed by wonderful Strand Lines. One of the big ways to get big erratics is to have a rock slide land on the glacier. Then all of those rocks, that entire rock slide, will get incorporated into the ice and the icebergs, And they haven't been rounded at all. They're as rough as they were when they were in a landslide. Then the iceberg will take them somewhere and drop them, and they're not rounded at all. We have all kinds of erratics, and you have to really be thinking.
An erratic scavenger hunt is an entertaining way to explore the Glacial Lake Missoula activity. Find a lone boulder, snap a photo, and then try to determine where it came from. How far away is a rock of similar composition? Montana Natural History Center is interested in what you can find in and around the Missoula Valley. Post it on Instagram with hashtag Montana Natural History Center.
Megadunes, colks, and scablands, oh my! Knowing a bit of these geologic events as you travel the byways of western Montana helps you spy other clues left among the mountain valleys. As the river swirled through the narrow canyons, the velocity of the floodwaters increased. Sediment, gravel, and rock tumbled in the latte-colored whitewater. At Tarkio, the river course snaked through the canyon and slowed just long enough to drop gravel in a giant dune 500 feet above today's riverbed. The rounded rocks are the size of baseballs and footballs. This megadune is the biggest pile of gravel deposited by the flood. Megadunes and gulch fills are reminiscent of gravel bars among many western Montana rivers. Rocky holes and circular ponds certainly look out of place. What caused these? Imagine a water vortex, a spinning, abrasive tornado, more powerful than any drill bit auguring basins out of bedrock. These are colks, made by hydraulic whirlpools and filled with debris as the floodwaters rushed west toward the ocean. Water moving at 65 miles an hour, almost freeway speed, sped down the path of the Clark Fork River, leaving behind a wounded landscape called scablands. Small areas of scabland can be viewed along the banks of today's river in various places.
To define megadunes, you have to think of what are dunes. And dunes are in rivers. They're like ripples in a river that are usually on the order of, are like 10 inches high to a few feet high. But in these big floods, like in the draining of Glacial Lake Missoula, megadunes are 30 feet high, 100 feet high, and up to 400 feet high. So they're like what you see in a stream, but just on a much larger scale. So Glacial Lake Missoula was very deep when it was at its high stand. And it drained very rapidly by the failure of the ice dam. So the water was rushing through the canyons at very high speed, at such a high speed that it was picking up gravel and just carrying it along in the stream. The gravel wasn't bouncing along the bottom. It was being carried throughout the flood height. And then as it was snaking through the Clark Fork Canyon, there were places where the velocities went down a little bit, and they started depositing these dune structures. Well, what you see on these dune structures is they're shallow on the upstream side, and they're deep. They're more steep on the downstream side, and they're up as much as 500 feet above the river level. So the normal river didn't deposit these things. It must have been a deep flowing flood through the canyons that was over 1,000 feet deep. When I started working in the late 90s, and ever since then, I'm discovering more and more things to investigate that haven't been investigated previously.
Becoming a practiced geological observer promises delightful road trips. Once on the trail of clues echoing through the centuries, you will be surprised at where the tracks will take you. Snap a photo and post it on Instagram with hashtag Montana Natural History Center.
The story of Glacial Lake Missoula is echoed in the scoured scablands west of the Missoula region. The massive flood, ice rafts, gravel, and sediment continued its frantic course through Idaho's Panhandle, the barren but beautiful channeled scablands of eastern Washington, and the gorge of the Columbia River and the Pacific. The devastation left behind has been compared to the surface of Mars. Mars rovers have crawled the scablands, simulating a Martian invasion.
the dam broke, the water went downstream. That means it went through Idaho, into eastern Washington, spilled across much of Washington, and eventually funneled down the Columbia River Gorge. It slopped up in the Willamette Valley beyond Corvallis, and then went out to the ocean downstream from Portland. And some of that water, we have good evidence that it went all the way up to Vancouver Island in the deep sea to 10,000 feet below sea surface. There's sediments offshore Vancouver, British Columbia, that we can tie back to rocks in Montana.
As you travel west, follow the Ice Age Flood Institute's geological trail. Snap some photos and post them on Instagram with hashtag Montana Natural History Center.
Curious geological sleuths like J. Harlan Bretz, Joseph Pardee, and David Alt have described our home landscape by following the clues left in the soil, cliffs, and riverbeds of western Montana. The case continues to be fleshed out by present-day detectives using increasingly sophisticated technological tools. The Floodies of the Missoula chapter of the Ice Age Flood Institute have developed a driving map and educational information to help everyone understand the impact of the flood and the story of the land in the Missoula region. The driving route is part of the larger Ice Age Floods Geologic Trail. The trail is a network of routes connecting interpretive facilities about the path of the Great Flood and is the first of its kind in the U.S. From the first indigenous people living on the land to today's students and scientists, curious people have been asking questions, observing the phenomenon, and slowly filling in the story of how our landscape was formed and what we might learn about the future.
A lot of people have heard of carbon-14 dating, where you can date bones, you can date teeth, and you can date burned wood. Unfortunately, you don't find any of that in the Glacial Lake Missoula section. And so there's a new technique. You can date the last time quartz or feldspar was exposed to the sun. And so it builds up, changes in its structure by natural radiation from the sediment around it, if you bury it. And then when you expose it to the sun, it luminesces ever so slightly. And so that's what I've been using to date both the silt beds of the glacial lake deposits and now dating gravels for when the gravels were buried.
Water is the most important thing at the surface of the earth that shapes the earth. So when we look at rocks, what we're really doing is looking at the history of the hydrology of that particular area. And so when we look for this evidence of Glacial Lake Missoula, what we're looking at is records of how the water at that time was shaping the landscape. And those records are left behind when the water left.
The story of Glacial Lake Missoula is not fully written yet. Be a part of the saga. Be curious, and be amazed by what is in your own backyard.
There are hundreds of phenomena still undiscovered out there. Find some, take a photo, get the GPS coordinates, and post it. Hashtag Montana Natural History Center.
Thank you, Jim, and thank you, Lynn, very much for your informative program. And I'm sure if you accept more questions if people had them.
Yeah.
or, but
I'm not a geologist, but I've been to the Flathead area many times, and I have been told that the glaciers were built up in the Flathead area, and they moved and they scoured out the lake and moved down as far as Evero Hill, and they stopped and deposited there, and they receded evidently, and then a second time they came by and they moved out again and they made another deposit where the Ravalli Hill is. And if you look at it from up there, it looks like it's very possible.
I don't think there's any evidence the big ice got to Evero. There was a steady stream. There's like 4 little mountain glaciers coming off in the Evero area to the east. They may have managed to flow across the little prairie there, but that would have been mountain ice. That wouldn't have been continental ice. The most controversial thing that you mentioned is in the St. Ignatius area. There's a big ramp. It goes from St. Ignatius up to the foot of the Polson Moraine. Now, the Polson Moraine is definitely a terminal moraine, and it was definitely made by continental ice. The ramp going down to St. Ignatius is similar to Glacial Till, but it's even more similar to Glacial Till that's been involved in been liquefied into a big mudslide. So it is now reinterpreted. The Polson Moraine as the terminus of the continental ice, that has, as our buddy Saddam Hussein would say, is the mother of all mud piles. And periodically Lake Missoula would build up to 1,000 feet deep against that face and even liquefy that mud more. Any disturbance of that mud then would trigger a large mudslide. And so that big ramp going down to St. Ignatius is now interpreted as the top of that mudslide. And still the farthest south we have really good evidence for the continental ice getting is the Polson Moraine. Now, sort of to go along with that, next time you're up there, notice the mountains, the Mission Range. And from the Polson Moraine southward, they're very alpine. They got snaggledy teeth tops, and they're extremely steep side slopes. And that tells you that was alpine ice, the 1,000-foot thick stuff, not the big stuff. Just as you get to the Polson Moraine, actually it's just a hair south, which may have been from one of the earlier, older ice ages, but there you start to see the sharp sawteeth start getting ground off. And by the time, and they get ground off more and more until you get to Big Fork, at which point the Swan River Glacier, which was running north, hit the continental ice and was forced over and completely overrode the Mission Range. And so you see in the mountains themselves the influence of increasingly deeper ice big enough to override the entire mountain range. That is clearly continental ice also. So those two lines of evidence, where the mountain was overridden and the terminal moraine that we know as a continental terminal moraine, come together at the Polson Moraine, and that is why we say that's how far the big ice got. Everything south of that is either the big mud flow or it's a phenomenon of mountain ice.
You have to keep not on. The one more sentence you needed to add, and that was that Flathead Lake was draining due west rather than south at one point in time.
Yes. And there again, that's a nice trip in its own right. The people of Kalispell have put together a bus trip and a bus trip handout for that trip, and it's the Western posse of Western historians up there. You might know those guys. If you drop them a line, they might send you a packet of those handouts, and you can drive up there and see it. But yeah, that's when Lake Missoula was out there. Well, at Elmo, that little hill behind Elmo, that's a terminal moraine also. And then you have Chief Cliff over here. There was an ice marginal river about 4 times the size of the Columbia coming down that side around Chief Cliff. The meltwater off of the main part of Flathead Lake is coming in right over Elmo and a little bit to the south. They run into Big Draw and come to and make a giant river. Now, when you look at Big Draw, imagine the Copper River in Alaska, a gigantic river, 10 times the size of the Columbia, 5 times the size of the Columbia, completely choked with mud and rocks. If you throw a rock in it, a rock has to fall out somewhere. It can't carry any more mud and rocks. And that was the drainage of Flathead Lake when Lake Missoula was out. As Lake Missoula comes in, then it starts to build up and fill the valley up. The other cute part of the story is when the Ice Age was the deep part of the lake is over next to the mountains, and the deep part of the old valley is over next to the mountains. At the end of the Ice Age, when everything let back down, it let the river down on the hardest bedrock ridge it could find. If it was in its original old valley, Flathead Lake would be dry, and we would have a Grand Canyon of the Flathead going down through there. But it got the river got let down on a very hard quartz and argillite ridge, and that's what's holding up the lake now. If anything ever happens to it, Flathead Lake is capable of. It's daylighted now. Is the dam where the dam is. The height of the dam. If anything were to happen to that little bedrock ridge, that's how much a Flathead Lake would be available to drain.
The additional idea is
someplace around 9 Pipe up to the north is this loaded with these depression duck ponds.
Yes.
And they don't have water coming in or out, but they get filled with water every spring, and the ducks do. I won't say that in a mixed crowd here. But you can explain that as part of a glacial geology phenomenon?
Yes. 9 Pipes itself is a pingo, and a pingo forms where you have high groundwater, a lot of groundwater feeding into a place, but it starts to freeze, and but the groundwater is somewhat insulated either by peat or snow or muck, so the groundwater doesn't freeze, but at some place in the groundwater, ice gets started. And so it makes an ice lens, but the groundwater keeps pouring liquid water into the ice lens. So this thing grows like a big blister until it gets tall enough, all the mud and the muck slides off of the blister. Then when it melts, you have a circular lake with a little tiny rampart levee around it, and that's a pingo. And that's the original pond at 9 Pipe, before they augmented it with the dam, was a pingo. Now there's a couple of other pingos up there, but almost all of the rest of them are kettles. And kettles occur. Kettle moraine? What? Kettle moraine? No, it's kettles on a mud flat. Now remember, we had the moraine was liquefying and heading toward St. Ignatius in a series of big mud flows. Then those mud flows are that flat surface. Okay, but it's mud, it's mucky. Lake Missoula would be 1,000 feet deep up against the ice. Lake Missoula would burst. That would go down very rapidly. As part of that rapid drop, what you have going back at the face of the dam is the lake was holding up a certain portion of the ice. With the lake gone, then it landslides into the lake as it retreats. So you've got basically a iceberg slush from the dam out into the valley there. When you drain all the water off and there's no more water to float the slush, okay, then all of that stuff melts. Now remember, it's really gooey, as you say, related to biologic processes and duck stuff, so it has no strength. When an iceberg sits on it, it squashes out a little depression. Then the iceberg melts, and you have your little round ponds. Those are kettles.
I think we're going to stop there. Everybody's very patient.
If anybody wants to see the actual ripples up on Camas Prairie, you go past Dixon, take the Hot Springs Bridge across Flathead River, and then go up there, and it's just before you cross the pass, and you can see it coming and going.